Hello, everybody. Thank you for joining us tonight and waiting in the lobby for a while. Today, we will talk about a geostationary satellite called QO-100. I'm Baris Dinc, OH2UDS, or Tango Alpha 7 Whiskey. Let me show you what we will talk about. We will start with introducing myself, my group, my friends, and I will give some brief information about QO-100, the equipment, how to get on QO-100 easily. Then the main topic, the activities we had on QO-100. We had a lot of fun and we would like to share all our experience with you. Maybe one day you and we will be on the satellite having more fun with the new activities. We will talk about our dreams, our group team dreams, how they come true. And of course, nowadays in Turkey, we use the satellite for emergency communication. That showed how important this satellite is for emergency communication as well. Then we will talk about some meetups and what can we do more on QO-100. So who am I? I am Baris Dinc, Tango Alpha 7 Whiskey, Oscar Hotel 2 Uniform Delta Sierra. Those are my current call signs. I had Azerbaijan call sign and US call sign as well, but they're all off now. I'm using these, I'm active with these call signs only. I started this hobby since 1980s. I would like to say 1980s because it was forbidden before 1980 in Turkey. So I cannot say I started before that. When I was a very, 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 very small kid, I started by reading the magazines of ham radio, and that helped me a lot. I learned a lot from this hobby, and now I'm a professional electronics engineer. I can say I'm using what I learned from this hobby. And also I'm the founder of Mars on Earth project that we will talk about today. So who we are, when I say Mars on Earth project, who is Mars on Earth project? We are a nonprofit community, a small organization set up by two daughters, me, Ruha, and our daughters. We were 4 people in the beginning only. Now we are thousands all around the world, and we have a lot of volunteers from engineers, instructors, teachers, and radio enthusiasts from every kind of professionals. And the common topic we have is space and space communication. So our main goal is to have a space awareness for kids, for youngsters, for everybody, I can say. So if you're interested in space, you can join to Mars on Earth project. QO-100, it's a satellite. It's a geostationary satellite sitting there 36,000 kilometers away from us. It's a geostationary, so it has the same speed as the Earth turns. So we always see the satellite at the same location, at the same place. It enters space at 2018 with a SpaceX Falcon 9 rocket. It's at 26 degrees east every time, not like the LEO or the Monlia satellites. They are not traveling all around. It's always there because it's a telecommunication and TV satellite. Originally, it's a Qatari TV satellite, but with the AMSAT deal, the amateurs from Germany, they collaborated with the Qatar amateur community, and they bring this QO-100 alive. The company Mitsubishi Electric built the satellite, and they deployed it on the satellite in 2018. And since then, it's working perfectly. It has an amateur transponder on it, which is 500 kilohertz for a narrowband and 800 megahertz for wideband, which is real TV transmission or live video chat capabilities. The downlink from the satellite to Earth is on 3-centimeter band, which is at 10.45 gigahertz, and the uplink to the satellite is 2.4 gigahertz, which is the 13-centimeter ham radio band. As you see in this picture, this is the coverage of the satellite. It's huge, from North Pole to South Pole, from Brazil, let's say South America to the eastern part. It's covering roughly 40-something% of the whole world. I can say a lot of population in this area. So when you get online, you will find a lot people working on this satellite. I think there are thousands now, and you don't need any propagation, or you don't need to wait for a satellite. It's always there. Just turn on your radio, no propagation, no nothing. I can say it's a telephone quality audio or TV quality video transmission over the satellite is possible. I'm living in Finland, so I'm at the top, nearly close to the edge. It's not easy to communicate all these areas over HF or VHF, but with QO-100, it's just turning on the radio. As you can see, in South America, there are some areas that can get onto the satellite. We have a lot of Papa Yankees on the satellite. Even I know that there were some experiments to get to the satellite from the North America as well. We would like to hear them more. And also the South Pole. We have a station in South Pole as well. They have a lot of pileups, but you can work with them. So this is the band plan of the satellite. As you can see, we uplink at 2.4 gigahertz and we downlink at 10 gigahertz. And narrowband, originally it was 250 kilohertz. It's now 500 kilohertz and 8 megahertz for a lot of video transmissions back and forth. The uplink is right-hand circular polarized, and the downlink, we receive the video on horizontal and we receive the narrowband SSB or digital modes on the vertical. Yep. As you can see, narrowband and wideband, and on the downlink side, horizontal and vertical polarization from the satellite. So what is needed for QO-100 SSB narrowband? It's very easy. If you have a satellite dish with any LMB, let's say it has a 9750 megahertz of IF frequency, then just feeding some energy to that LMB using a bias T or DC injector and trying to listen 739 megahertz with any USB stick, because the satellite is at 10.49. If you subtract this local oscillator, you will get 749. So any SDR receiver can listen that. And there are many good softwares all around that you can use to listen the SSB communication on the satellite. Of course, you can use the same setup to decode the video or data transmissions coming from the QO-100 satellite. Or if you don't like computers or software-defined radios, you can use a down converter to your VHF, UHF, or maybe your HF radio. Then you can use any SSB-capable radio to receive the communications on the satellite. Yep, this is a sample. This is something I use also. The Adam Pluto from Analog Devices is a great SDR device, which is capable of receiving and transmitting. So we use some Wi-Fi amplifiers to amplify our signal through a patch antenna or maybe a helix antenna. Then we use for transmitting signal to the satellite. And for the receiving side, we have the LMB, the dish, the DC injector to LMB, and directly we can listen what's coming out from the LMB, and we can use any SDR software. My favorite is SDR console. You can use to communicate two-way communication via the satellite, even video communication, which is digital amateur TV. Yeah, let's come to main topic. It was pandemic days. Everywhere closed. We trapped in our houses. The only way for communication was to use some online environment to talk each other. But we, as Mars on Earth project, we were also discussing how we can do some activities with our volunteers all around the world. We have many volunteers. We were preparing our environment in Turkey to have a Mars, mimic Mars on Earth, that we will have space communication stations, astronaut training stations, rovers, etc. And we were planning to have some fun with the kids in our environment. But pandemic didn't allow us to do this, but gave us another chance to have fun with all the kids all around the world. Let me tell you how. We started thinking what we can do with kids, let's say online. We thought some online tools. We discussed which tool to use. Then we come up with an idea that we are ham radio enthusiasts, so let's do it over the radio frequency. Yeah, this is Mars on Earth project. It should be related to space. We should have kids, youngsters, families, ham radio operators all around the world to involve in this activity. Ham radio is the key, and it should be something new and interesting, maybe something never done before. Yes, we can do something on QO-100, we thought, but in Turkey it was not allowed to transmit to satellite. Still, 2.4 gigahertz, the 13 centimeter band is not allowed in Turkey. I hope soon it will be allowed, but while we were doing this, it was forbidden to use. So what about the receive-only activity? We transmit from, let's say, Finland, from Germany, and people in Turkey and all around the world can receive that. And we decided to have minimum equipment requirement on the user side, because they are kids, maybe they don't have radios. Even some web SDRs should be useful in this case. Yes, we thought, why not QO-100? And we decided to do something with QO-100. So the first idea, the first one, we asked kids to draw their imagination about how is the life in Mars, in future, in past, now. Just wanted them to picture it out. And we thought that we will have 20, 30 pictures that we can send to space. And on the right bottom corner, you can see sending to space. We decided to use the KGSTV protocol to send them to the QO-100. QO-100 will downlink them to the world, so any SDR receiver can receive those. But at the same time, when you send something to satellite, it goes beyond the satellite. It goes to the universe. So we said we will send your pictures to the universe. And kids started drawing. We prepared some videos, training videos for the kids to how to decode these videos or these pictures through a satellite dish with an SDR receiver, or maybe they can use any web SDR server like the British Amateur Television Club SDR or India CR0 SGB, I guess. That was a great SDR, helped us a lot during our activity. So yeah, we published our training videos. Kids sent us pictures. We thought that it will be only 20, 30 pictures, and it will take only 1 day to transmit those pictures, because each picture was taken 5 minutes, 6 minutes to transmit. And the transmitter was getting hot, but we got roughly 200 pictures. So it was not only a weekend project for us. We spent all the weekends of 2 months to transmit all those pictures to space. And we had a lot of attendees from all around the world. They sent us what they captured. We sent them the certificates, the award certificates that they attended to this activity. And we had we had families in this game, in this fun as well. Fathers, mothers with the kids, they were trying to align the dishes and receive this. It was all fun for us as well. Yeah, some sample pictures from the kids. They are brilliant. We we got a lot of feedback from the radio amateurs that this was a very good activity on the KG-STV, which is kind of SSTV on the satellite. Then the second activity, we started thinking about what else we can do. And we come up with the idea of fox hunting. Fox hunting, you just put some little transceivers into a forest, and you leave people there with receivers to find those transmitters. It's pandemic days, we cannot go out, so we decided to do exactly the same activity on the satellite. Yes, we selected 4 frequencies, and we said we will transmit randomly on one of these frequencies. And we have a pattern that the first 5 seconds will be some tones. Then we asked young people to store or record their messages for space of 15 seconds and send them to us. So then after this Billy, then we played the 15-second message from a young guy to space. Then every attendee gave a secret letter. For example, assume that my secret letter is H, so I said, and my secret letter is hotel. So we put all these in a sequence, and we asked people to capture all these secret letters and messages, record them, log them, and send us their log and audio recordings. And also we want them to capture the whole sentence, which was somewhere something incredible is waiting to be known by Carl Sagan. And we had a lot of attendees to this activity as well. We prepared the certificates. We sent the certificates back to them. I believe they had a lot of fun. Then we started a virtual mission in our MOAB team, which was training analog astronauts. We had 7 young lady. They were communicating over the virtual environment. They assumed to be the crew in Mars, and we were sending them daily tasks with video mails over the QO-100, and they were conducting their tasks and reporting back over QO-100. So on the left side, you see Oscar Hotel 2 Charlie Alpha Victor recording her video mail with the tasks. That task was sent to satellite using the Finland station Oscar Hotel 2 UDS, and all this transmission was live over the satellite, a video transmission, which was captured in Germany by Mr. Ismail, Delta Lima 2 India Echo, and transferred to the crew. And also their results transmitted back to Finland from Germany to Finland. So Germany playing the Mars Space communication station, and Oscar Hotel 2 UDS playing the Earth communication station. And it was fun of 7 days. This activity was 7 days, and it was live over QO-100 satellite. Yes, we are dreaming, and we are praying to have our dreams to come real. During the pandemic days, we started thinking about a radio astronomy and satellite ground station, and we were looking for sponsors, and we were just drawing some sketches, 3D sketches, to make this real. And it became real right after the pandemic with our activities. Now we have station at Ankara University Observatory, Kraken Observatory. We have 2 dishes, 2 big dishes, an operations center with full of computers and SDR receivers, and we have VHF, UHF antenna setup for ham radio satellites monitoring. We called this station Tango Alpha 2 Tahir Dengiz, the silent key, and we gave his name to this station because this was our common dream that we were dreaming about. So what other activities can we have over the QO-100 satellite. I can say we are thinking about a treasure hunt over QO-100 or a sea battle over QO-100. We just didn't decide, will it be a video transmission or will it be an SSP transmission yet? But we are collecting all the ideas from young people. Soon we will have some better games on QO-100. Yep, maybe you heard that in February, Turkey had a big earthquake, even 2 earthquakes. And during that period, Turkey is not allowed to use 2.4 gigahertz uplink, but we got a special permission to use 2.4 gigahertz, and we sent some satellite communication equipment to the field and tried to communicate with those over the satellite and tried to show that how important this satellite is for emergency communication. It's really important. It's 7124 up there. It's always receiving, it's always transponding our signals back. So any small size dish can communicate over this satellite. Here you see the people who worked with us over the satellite during that period. As far as I know, still some Turkish stations are online on the satellite. So we ask for permission to use this satellite and have some experience on satellite communication. We still have the limited permission, but our hope is to have the 2.4 gigahertz band opened in Turkey. We had a meetup in Istanbul in 2022. We called it Tango Charlie 100 Quebec Oscar Station. Roughly 100 ham radio enthusiasts from Turkey gathered together. We set up a DATV and an SSP station. We had contacts with hundreds of stations over the satellite, even the Delta Papa Zero Golf Victor November South Pole station, thanks to all the guys there for contacting. And in 2023, while I'm recording this still not happened, but will happen in 2 weeks. We will have a meetup in Ankara, the capital city of Turkey, and we will talk about QO-100. We will have some training about QO-100, and we will ask people to gather their equipment to work on to this satellite. Also, in parallel, we are working on a MEMPAC QO-100 transceiver. It's an ongoing project with all my friends from Turkey. We are thinking this is an emergency communication transceiver where you can get into any emergency situation, or maybe another sort of activity over QO-100. Why not? Thank you for listening. Now I can have the questions, but please note our social media links for the Mars on Earth project. We would like to hear about your ideas, what we can do on the satellite together. So thank you very much. Let's continue with the questions. Thank you.